Alrighty, let's get started. Cool. Welcome. We've got another LogRocket meetup tonight. Particularly excited about this one because I need a new alternative to browser sync, which I've been using for too long. So yeah, today we've got Ashley Davis. I'll let him introduce himself a little more. He's been a LogRocket blog author for a long time. And today, yeah, we're talking about live reload, what it is, why you need to do it, and how to do it. And this is based on a post that just went up yesterday. I just put it in the chat. I'll also be sharing the recording and sharing all the links from relevant links. Most of them, I assume, are in this post after the meetup. So yeah, just quickly, this meetup's brought to you by LogRocket. And yeah, LogRocket's a front-end performance monitoring solution for all your web, mobile apps and websites, everything. So I think, it really fits in with what we're talking about today, which is, really rapid development, in development rather than production. And then once you're really quickly releasing stuff into production, being able to monitor those new features and how people are interacting with them, making sure they're functioning, is really critical for just ensuring all the hard work you're doing is actually functioning. So here we're looking at a LogRocket dashboard, and say we've been using live reload to develop a brand new feature that's a really critical workflow in our app. We've got this funnel here where someone's starting an evaluation, looking at solutions and setting criteria, and say we can assign some revenue to it. We can actually go see exactly who did this stuff and then maybe who didn't. And then all the issues that might be happening along that path. So after, we can see that, there's a frustrating network request along this path, and go look into that and go actually see the people who are affected by it. So yeah, I just wanted to quickly show how LogRocket basically links session replay with analytics in your applications to ship features a lot more quickly, and then fix them even more quickly after you've done lots of testing and development. And then what works on your machine doesn't work in production. So with that said, I'm going to shut up and I'm going to turn it over to Ashley.
Hello. Can you hear me?
Yep.
Cool. Thanks, Luke. Am I good to start presenting?
Yes, sir.
All right, cool. Thank you. Well, g'day, everyone. I'm from Australia. My name's Ashley Davis. I've recently written a blog post for LogRocket called Live Reload Across the Stack. Well, that's what I called it. I think we named it to the complete guide to live reload. But this talk today, anyway, is Live Reload Across the Stack. I'm doing a deep dive on what was on the content in that blog post. I'm going to try and get through all of it. There's a fair bit. Hopefully, we're not going to run out of time. I'm going to try and keep this to an hour. In fact, I'm just going to set my timer just so I know how much time I'm chewing up. Just give me a second. There we go. That should be good. Now, before we start, though, I'd like to start with a tradition that we have here in Australia. I'd like to acknowledge the traditional owners of the land from which I'm broadcasting, and I'd also like to pay my respects to elders past and present. Now just let me share my screen. Cool. Before we get into it, I will just show you where you can find the blog post, and I'll show you where you can kind of find the code as well. And if you want to, you can follow along today. So if you're quick at cloning the repo or downloading it, you can follow along. So for the blog post, look on blog.logrocket.com, complete guide to full stack live reload. You're going to see a bunch of diagrams in my talk. The diagrams are all from the blog post, so you don't have to kind of spend a lot of time, during this talk reading these diagrams. You can come to the blog post to look at them.
The links in the chat.
Oh, yeah, cool. And you might want to link in the code as well. So the code is available on my GitHub account, Ashley Davis. Look for live reload examples. We've got 9 different examples here, starting out with a simple Node.js application. We've got some front-end stuff in the middle, and we've got Docker at the end. So if you really want to see live reload working with Docker, that's the really cool bit. You'll have to wait till the end of the talk for that. But yeah, feel free to grab the code from here. You can download the zip file from GitHub directly, or you can copy the link here and clone the repo for yourself. So it's not too hard to get the code and get started. I promise you, all these examples are simple to create and simple to get working, maybe not Docker and maybe not Webpack, but most of the other ones are fairly simple. So we are going to start off simple as well, and it will get a bit more complicated as we go through. Just let me get myself organized. Cool. So I'll start with a little bit about myself. I am the VP of Engineering at Hone. We are a startup that is building exciting DeFi technology product on the Algorand blockchain. I'm the developer of Dataforge Notebook, which is like Jupyter Notebook, but for JavaScript and TypeScript. And that's something that I'm open sourcing this year. So keep an eye on that. I've written a couple of books, and I'm currently writing my 3rd book. My first book was Data Wrangling with JavaScript. So this is a guide to show JavaScript developers how to work with data. And it's to show you that you don't really need Python. Everything you need for working with data, or most of what you need at least, is already in JavaScript. And this book shows you how to use it. My second book is Bootstrapping Microservices. And it's a practical guide to working with microservices, starting with nothing, then creating a single microservice, and then scaling up to multiple microservices in development on your development PC, but also deploying it later on to a production Kubernetes cluster that you create. And I guide you through that process in this book. My new book is called Rapid Full Stack Development. I'm currently just starting to work on it. Why am I writing this book? Well, it's on a topic that's really important to me, because I think I believe it's, not enough just to survive as a developer, but we should also be able to flourish and be really effective developers. So, this book is something that satisfies that need, and you can learn from my experience, and you can grow into a more efficient, effective developer. Check out the webpage there if you want to learn more. So, getting feedback quickly while you're coding is a really fundamental aspect of maintaining a rapid pace of development. Writing code is not going to be our only concern. The code we write needs to be valuable and reliable. Is your code going to be valuable? Well, that's something only you can decide, or maybe only your company can decide. Is your code going to be reliable? Well, that is something that you have to test for yourself. And you must run your code frequently to check its output and behavior to make sure that you are developing reliable and robust code. We can create a more seamless workflow by having our application automatically reload. That's what we call live reload. And we do this during development. So in this talk, we're going to examine a variety of techniques for live reload to automate the run it part of your development pipeline. So wise use of these techniques, it's going to help you become a faster and more efficient developer. Live reload, to put it simply, it's the automated approach to restarting our application during development. Now, we do this so that our application automatically picks up code changes while we're coding. And doing this is going to save us countless manual and tedious restarts of our application. Now, you've probably heard of this technique already, because it's really quite typical for web developers to use live reload while they're developing a web page. They're editing the HTML, the JavaScript, and the CSS, and the browser automatically reloads the page as you're working. But you may not know that we can apply this technique across our stack. So this is actually a full stack technique that we can use in the front end and the back end. We can even use it for mobile development, which I'm not going to cover today. But you can see here in this diagram that the part that is labeled, this part can be automated. So the part between coding and running the code, that's where live reload fits into our coding cycle. Now, don't try and read all this diagram. You don't need to read it, while I'm talking. You can look at the blog post and have a detailed look at this later if you want. So this diagram shows the coding cycle unfolded over multiple iterations. It's like a bird's eye view of the process of development. And through this process, we take our code from working state to working state, accumulating working code and minimizing the buildup of bugs and other issues. Now, any improvements that we can make to each small iteration of coding here is going to have an amplified effect on the overall development process. So live reload, it can have a dramatic effect on our performance, not just because it takes these boring and manual restarts of our application or reloads of our web page and automates them, but also because it can be scaled up. So to start, it can be scaled across the many processes in our application. So you may have it running across multiple microservices, for example. You might have multiple suites of automated tests that are live reloading to rerun your tests. You might have several web pages open that that's an extreme example. But you can see that if you have a complex application with many working parts, you can use live reload across all of the parts and scale it over the different parts of your application. Now, live reload also is automatically scaled across the iterations that you see here on the diagram. So it's automatically scaled across the iterations in your development process. And it also has the positive side effect that it encourages small changes and frequent testing. And so both of those things help a developer produce reliable and robust code. Now, all these benefits considered is why live reload is part of the foundation or the bedrock of my own development practice. It's part of my philosophy of coding, and it's a core technique in my book, Rapid Full Stack Development. Now, before we get into the examples, I just want to point out that live reload techniques are presented here are to be used in development only. Our needs for production are going to be quite different. For example, towards the end of this talk, I'm going to be showing a demonstration with Docker. And in production, we want to build Docker images that are optimized, that are secure, that have the code baked into them, and the code is going to be immutable, so it can't be changed. So that's for production. But in development, we'd prefer to have Docker images that are not optimized. So they're easy to understand, easy to debug, and where the code is mutable. The code has to be mutable. We have to be able to change the code inside a Docker container in order to get live reload working for it. So the needs of development and production are quite different. And today I'm only talking about development. In a future talk, I might come back and talk about the needs of production. But today it's just all about development. Now we're going to start looking at some code examples. For each code example, I've got like a diagram to go with it. And I've got a bit of an explanation to give you as well. And then we're going to actually look at the code and run the code and see the code in action. Now, if you get lost in any of the details in this talk, don't worry. I would encourage you to go and look at the blog post to remind yourself of how to run the code and how to use it and how it works. And I'd also remind you to actually get the code. Clone the code for yourself. And I'll show. We'll see that in a moment. But follow along, try it out. There's no way to get better at development without practicing. So feel free to grab the code, play with it, and see how live reload works for yourself. Now, the first tool we're going to be looking at is called Nodemon, and it's a way to get live reload working for a Node.js application. Nodemon itself is a package that's available on NPM. That's the Node package repository, so it's really easy to install. I like to think of Nodemon as a drop-in replacement for Node. It's not really. It is a package that runs under Node, but when you run it, like normally when you run a Node.js program, you're running Node and then the file like index.js or something like that, right? When you run Nodemon, you replace the Node bit with Nodemon, so it's Nodemon index.js, something like that. I'll show you that in a moment in the demo, but it's that simple. It's really replacing Node with Nodemon. And then what Nodemon's going to do is it's going to watch your code for changes. And if any of the code changes, it's going to restart Node and run your script again. So it's going to do that repeatedly as you're editing your code. So let's switch over to the first example. And I hope the demo gods are smiling on me today. I'll just go back again, just to remind you where to get the code. It's on my GitHub account, Ashley Davis, under live reload examples. You can either download the zip file and unzip it, or I'll just show you here. You can copy the URL here. Go to your terminal, and then you can do a git clone of that URL, and that'll get a local version of it. and then you can CD into that repo and then start working with it. Now, I've already got the code in this directory here, and I've installed all the dependencies and stuff, but I'm going to show you how to do all that stuff still, all the setup stuff. Now, to run these examples, you're going to need Node.js, at least to run, I think, the first 7 examples. You'll need Node.js, so you can get that from nodejs.org, easy to download and install for any platform. You'll also, if you want to run the Docker examples, so that's the last 2 examples, you're going to need Docker Desktop installed. Really easy to install for Mac. I don't know about, I've never installed Docker Desktop on Linux. I've used Docker on Linux, but not Docker Desktop. It's a little bit harder to install on Windows because you need to install a thing called WSL2. But if you use Windows like I do, it's well worth it, and it's definitely doable. It's just not as easy as Mac OS. So as I said, I'm working on Windows. I'm working on Windows 11, although pretty much everything I'm going to show you today is going to work on Windows, Mac OS, or Linux. It doesn't matter. And in fact, I'm using Linux or Unixy style commands here because I've got Git for Windows installed, which gives me those commands. So even the commands, which aren't native Windows commands that I'm showing you today, they're all going to work on Mac OS and Linux. But if you want to use these same commands on Windows, you're going to have to get Git for Windows or some other package, some other thing that gives you these commands. Okay. So I'm running Node version 16. I'll just show you 16.14.0. I'll show you what version of Docker I'm running. So Docker version 20.10.12. So that's what I'm starting with here. Now you can see I've got all the examples here, numbered 1 through to 9. I'm going to go hopefully through most of these today. We'll see what we've got time for, see where we run out of time. Starting with the first example. Hang on, I lost my terminal. So I've just CD'd into the first example here. I'm going to start Visual Studio Code from this directory. Oh, I should add as well, when you get any of these examples, each one needs an npm install. So npm install grabs the dependencies that are needed for that Node.js project. And for this first example, the only thing we need is Nodemon. So that's the only thing that's been installed. And if you wanted to set this example up from scratch, all these examples, like except maybe the final ones, are pretty easy to set up. In this case, all you have to do is type npm init-y. So that gives you like a blank Node.js project. And then once you've got your blank project, you can do an npm install save dev Nodemon. So that'll save the Nodemon dependency into your project. The save dev argument here is what saves it as a development dependency, which means we can kind of differentiate between our production and our development dependencies, so that if we ever do deploy this service to production, we can easily eliminate the dev dependencies from the project. So Nodemon, again, like everything I'm doing today, everything I'm showing you today is for use in development. So that's why we're saving it as a development dependency. So let's jump back into Visual Studio Code. You can see here there's an index file. So this is kind of the entry point to the program. It's not a complicated program. It just prints hello world. That's it. So nothing too exciting in the code here. What's important though is that we can change this code and have the application automatically reload itself, while we're changing the code. And we have a package.json. So this is the kind of metadata for the Node.js project. It describes how to run the project in the scripts, which we'll come back to in a moment. And it describes the dependencies. So our only dev dependency so far is Nodemon, so version 2.0.15. When I did the npm install, it automatically grabbed that dependency. So we've already got that locally. Now, we've only got one file. There's only one JavaScript file here. If it was a more complicated application, there'd be multiple JavaScript files here, but it's really simple. It's really trivial, just to demonstrate live reload. I can easily run this just by running Node by itself with index.js. Okay, but if I want to run this in live reload mode, like I said before, you can think of Nodemon as like a drop-in replacement for Node. So I can run, instead of running node.js index.js, I'll run Nodemon index.js. So that starts my script in live reload mode with Nodemon. I can't just do that by itself though, because Nodemon is a locally installed package. It's not a global command or anything like that. To run a local command, a locally installed package with Node, we run the npx command. npx comes with Node.js, and it just allows us to run a local package, on the command line. So what I should get now is my simple Hello World Node.js application, but running in live reload mode. So you can see here, Nodemon has started up. It started Node index.js, and it's printed Hello World. And now it's waiting for changes before restart. So let's make some changes and see this live reload thing in action. So I'm back in my code here. I'm just going to change this to Hello Computer, if I can spell it properly. Hello Computer. I'm about to save it. I'm hitting Control-S to save it. And you can see on the left here, it's restarted due to changes. It's running the same program again. This time it's printing Hello Computer. So that is the most basic example of live reload you can get with Node.js, but it shows you how to run, a backend service, a microservice, something like that, a web server, whatever this ends up being. It's nothing yet, it's just Hello World, but whatever this ends up being, it's got live reload. So I can just merrily keep coding away and it will keep automatically restarting. Now, that's not all there is to the picture here. In package.json, you can see a bunch of scripts here. So to be a good Node.js developer, we should at least implement the start script. So what that means is when I run on the command line in the terminal here, when I run npm start, that's automatically going to run this start script, which is node index.js. So you can see that's run that here. So I ran npm start on my terminal, and it's run node index.js. So any Node.js developer with a little bit of experience is going to know that when they get your project to run npm start, that's how they know how to start your project. It's always going to be the same. This is a convention that we have in Node.js. So like I could have my main file here be main.js or server.js or whatever, and it can have whatever command line arguments it needs. And I don't have to, as a new developer working on this project, I don't have to know about that stuff. All I do is know to run npm start, which is the same for any Node.js program. So I'm just going to set it back to where it was. Now, my own personal convention for live reload is to have a script called start::dev. So this is what runs Nodemon index.js. So if I want to start my application in production, that's when I run npm start. If I want to run my my application in development, I always run npm start::dev. npm run start::dev, sorry. So that's going to start, as you can see here, that's starting Nodemon. And as before, it's run our program and it's waiting for changes before restart. So I can come back here and maybe I'll just change that back to Hello World and I'll save that. And you can see over here that it's automatically restarted and printed Hello World. So I'm sure you can agree that that's fairly simple. It's pretty easy to create a Node.js project with live reload built into it. And then just to be good Node.js citizens, we're going to kind of implement our scripts here so that other Node.js developers will know how to work with our project here. Now, I'm going to quickly stop on the next example, which is example 2 is basically the same as example 1, except I'll just start Visual Studio Code from example 2, except that in this example where I'm showing you how to configure Nodemon. So if we look at the package.json again here, we can see this time around the start dev script is just running Nodemon. There's no extra parameters there to tell Nodemon what script to run or what code file to run. To look at that, to find out what it's doing, is we have to look at this nodemon.json file. So nodemon.json, this is the configuration to Nodemon, things where we can tell it like, which directory contains our source code that we want to kind of watch for changes, which directory do we want to ignore. For example, if we had automated tests under this directory source test, we don't, this project's too trivial for it, but we don't have that. But if you did have automated tests, you don't really want them fitting into the live reload of your application, because automated testing is going to have its own live reload system, which you'll see very soon. And then this is the vital bit here, the exec field here, which tells it to run Node and index.js. So this is what kind of sets it up to run, and we can really customize the behavior of Nodemon in here. And I don't know if you've realized it yet, but Nodemon is incredibly flexible. Like, we're telling it what command to run. This thing is not hard coded to work with Node.js. Like you could run anything here, right? You could run a Python program. I don't know why you do that. You could run any other kind of code you want here. Assuming you've got the right software installed on your computer, of course. Now, one thing that I've done with Nodemon before is I've configured it to watch CSV files for changes. So I've configured it to watch data files, and when the data files change, we rerun a script on it. So it's like, it's a bit of an ad hoc way of, or a sort of a poor man's way of building a live reload data processing pipeline. But you can literally run any program, and you can watch any kind of files with Nodemon. So it's very flexible, and you could build all sorts of customized and interesting live reload pipelines with it. Okay, so back to the slides, and we're on to example number 3 now, which is TypeScript, just because I love TypeScript. So you might imagine that using TypeScript with Nodemon could be very difficult, because you have to build your TypeScript code to JavaScript, and then you'd have to kind of restart the application on the JavaScript code. Now this is totally possible to do this, and it's kind of complicated though. You'd have to have at least two commands running in parallel to achieve this. So it's a bit more tricky, but fortunately for us, there's a package called tsnode. And tsnode is another package that runs under Node.js, but it's also like Nodemon, you can kind of think of it as being a drop-in replacement for Node. So instead of running node index.js, I could run tsnode index.ts. So I can run my TypeScript code directly, at least it feels that way, but there's some magic happening under the hood to compile it and run it, of course. But it allows you as a developer to run your TypeScript code directly under Node, which is something you only want to do in development, of course. In production, you want to compile it to get the best performance out of your code. But in development, it's just really convenient to be able to directly run TypeScript code without having to compile it. And it's great for prototyping in TypeScript, and it's probably great for learning TypeScript as well, because you don't have to worry about bothering to set up a build pipeline. So this diagram here, it shows how we can run Node.js using tsnode to run our TypeScript code directly. We're going to use Nodemon the same way, basically. But this time around, Nodemon is going to be watching our TypeScript files, and it's going to be invoking tsnode instead of node. So let's have a look at the third example. So again, before you run any of these examples for yourself, after you've cloned the code repository, just run an npm install. That makes sure you get the dependencies. That's more important this time around, because now we've got dependencies on TypeScript and tsnode, and probably a couple of other things in there as well. So I'm just going to start Visual Studio Code from that directory. Okay. So let's have a look at the package.json. So we've got a bunch more dev dependencies in this project. You can see we've got the TypeScript compiler, so we need that to compile TypeScript to JavaScript. We've got tsnode, which is what I'm saying is the drop-in replacement for Node that we can use to directly run TypeScript code in our application. Of course, we've got Nodemon, which is going to watch our files and update. And we've also installed the TypeScript types for Node.js, which is it's not really part of this talk, but like you need that if you want to get kind of proper compilation and like TypeScript compilation, and it gives you all the static types for Node.js. We've also got a bunch more scripts. So the start script, now what it does is it runs Node and our compiled JavaScript file. So this start command here, it relies on the code already having been built, which we can do using the build command or the build script, which runs TypeScript in incremental mode. Incremental mode, if you've never seen it before, just makes subsequent compiles of the TypeScript code quicker. And of course, our start dev command here just runs Nodemon. Now, this time around, we've basically configured Nodemon a little bit differently. So this time around, we've configured it to watch files with the TS extension. So we've cut down the range of files that Nodemon is monitoring, and it's only going to monitor our TypeScript files. And then when we run it, Nodemon is going to run tsnode, and it's going to point it at our index.ts file. So our index.ts file is just, again, a really simple TypeScript code file that prints hello world. But just to show you that it is, prove that it is TypeScript, I've added a type there. So not this kind of hello world application can't really benefit from TypeScript, but I love TypeScript, a lot of people do, and bigger applications do benefit from it. And of course, you can use live reload with it. And let me show you now. So if you ever want to remember how to run any of this stuff, open the package.json file, have a look at the scripts. It tells you, we could run the build command, or we could literally copy this command out and run it from the command line. Now, because I'm running a local package, which is TSC, which is the TypeScript compiler, I would use npx to compile that. So what this is going to do is compile the TypeScript files to JavaScript. They will be under the build directory. So you can see that, well, I'll show you the source directory as well. So in the source directory, we have an index.ts. So that's our hello world TypeScript program. And in the build directory, we have the compiled version of that, which is basically the same thing, but compiled to JavaScript. Now that we've built it, now that this index.js exists, we can run this start command, or we could copy it out directly. So I could copy that out directly and run it. I'm just going to show you, like normally to build this, I wouldn't run TypeScript directly. I'd run npm run build. So that build script is like kind of one of my conventions about how I structure my build pipelines. And I could run npm start to run it. So we're just running JavaScript code at this point. Hello world from TypeScript. Now to run this in live reload, we run my personal convention npm run start dev. So this is what runs Nodemon. And then you have to look in the Nodemon.json configuration file to see what it's actually going to do and what kind of files it's going to monitor and where the files are that it's going to monitor. So I can now directly just change my file here. I'll do the hello computer again. I'll just save that by hitting Control S. Now you can see here that it's restarting. It's rerunning ts node index.ts and it's printing hello computer. So live reload working with TypeScript. Now we're moving pretty quickly here. The next example we're going to look at is how to use live reload with the testing framework Jest. Now, you might use a different testing framework. I think probably most of them have some form of live reload feature built in. You know, Jest, it's really easy to configure. There's like almost no configuration. In fact, it generates the configuration for you. So you don't need to worry about configuring anything. And live reload is built in. I've also used live reload with the Mocha testing framework. And probably earlier than that, other frameworks that I've used in the distant past. So, you know, it's not just Jest, like any automated testing framework you're going to get is probably going to support live reload. And it's enabled through a command line option, which I'm going to show you. So this diagram, it shows how Jest is going to watch our code, both the code for our application and our test code. And whenever any of it changes, it's going to automatically kind of rerun our automated tests. Now let's have a look at the example to see how that works. So I'm moving on to example number 4 here. And again, you'd want to do an npm install before you run this. I'm opening Visual Studio Code. Open up the package file. So the dev dependencies we got this time are just Nodemon for the actual application and Jest for testing for running our automated tests that test our application. So effectively in this project, we've got 2 live reload systems that are going to be running. So we've got, and you can have them running at the same time as well, which is really cool, but I'm not going to show you that. Now, Nodemon is the first one. So that's what we use to run our application. And Jest is what we use to run our automated testing. So Nodemon's got live reload to rerun our application, and Jest has live reload to rerun our automated tests. So we've got 2 different systems running here, both using live reload, both monitoring our code, but for different purposes, for slightly different purposes. Now, there's a really simple test here. This is a really simple Jest test that tests that true is truthy. Nothing complicated here, and you would hope this would be true. So let's look at how to run this. Now, to remind you how to run any decent Node.js application, if the developer has set it up properly, have a look at the package.json file. Look at the scripts. This will tell you what things you can do with this project. And it will tell you how to run these things as well. So this tells me, test::watch, by the way, is my kind of personal script convention for running Jest in live reload mode. And it automatically adds the watch command line argument there onto Jest, which basically makes Jest run in live reload mode. So now I know what things I need to do to kind of run this. So, you know, I could run the application by running npm start or npm start :dev, and I can test it by running the test script or test :watch. Now, test is important. It's important that if you have any automated tests, that you implement that for your Node.js project, because that is an official convention. So I can run npm test, and whether I'm using Jest or Mocha or whatever else, you know, that's going to run the command that runs my testing framework. So in this case, I've just got this one simple test that tests that truth is true. And in fact, running a bit slowly. Here we go. Come on, you can do it. Come on, Jest. There we go. So I've got one passing test. The truth is the truth. You like my naming there? But now, if I want to run this in live reload mode, I'll run my personal convention test :watch, which is what runs Jest, but with this watch command, this watch flag enabled. So it's going to be running in live reload mode. It's actually not going to run the tests at the moment. And that's because Jest by default, like it looks at Git and it looks at what's changed in Git to know what to run. And because nothing's changed in Git, Jest here thinks it's found no tests to run. So nothing's changed since the last commit. I could hit, it says here, press the A key to run all the tests. I could do that to run my tests, but it's just as easy to change them. So I'm just going to change this now, and you can see the live reload in action. So I've just changed that. That's going to fail because false is not truthy. I'm just saving that by hitting Control S, and you can see on the left there that the tests are automatically rerunning, and I've got a failed test now. So the beauty of automated testing and live reload is that you can be coding, and as you're coding, you can get this live, almost instant feedback that you've broken something. Isn't that awesome? Like, if presuming you've got good test coverage, not everyone does, but if you've got good test coverage, you can change something in the code and find out almost immediately if you've broken something. All right, I'm just going to set this back to true to fix my code. I'm just saving that, and again, it's got to the point where it says nothing's changed, so there's nothing to test. But I'll just hit the A key now, and it will do all the tests. It's running all the tests, and my test is passing again. So I think that's about all I need to show you with Jest. Again, if you're getting lost in any of the details here, please come back and have a look at the blog post, or you can come back and watch this video again on YouTube. It's all going to be there, and you can watch it at your leisure if you need to kind of more time to take this stuff in. Now, the next thing I want to show you, again, just because I love TypeScript, is how to use Jest with TypeScript with live reload enabled. Now, again, you could imagine, you know, this could be very difficult to implement because you'd have to compile your TypeScript code to JavaScript, and then you'd have to run Jest on that JavaScript. So there's like two commands that need to run in parallel to get this to work. But fortunately, there's no complication for us because we can use this plugin to Jest, which is available on the Node package repository or Node package library. It's called Jest. So this is a plugin to Jest that allows us to run TypeScript code directly under Jest. So that's going to be really convenient. Otherwise, we'd need this more convoluted build pipeline in order to use TypeScript for our code and for our tests. So this diagram here, it shows how TS-Jest kind of fits in with Jest. Jest is going to basically monitor our files and rerun them through this kind of like, it's almost like they're being filtered through TS-Jest before it's going to actually run the code that does the testing. So let's have a look at this example. So we are up to example number 5. Yep. And again, if you want to run this for yourself, you've got to run npm install first, otherwise it's not going to work for you. Let's do what we do and dive straight into the package.json file. So there's a lot more dev dependencies this time. So we've got, you know, Jest, we've got some types for Jest here. We're still going to be using Nodemon and TS Node because this is still a legitimate, you know, TypeScript Node.js application that we want to run. You know, we want to run the application with live reload so we can test it and edit it and have live reload kick in and, you know, continue to test it. We've got TypeScript installed because we need the TypeScript compiler, and we've got TS-Jest installed. So that is the plugin to Jest that allows us to run TypeScript code directly under Jest. We've got, you know, some of the usual script commands up here. Again, this tells you how to run this project. You can see that our testing, even though we've added TypeScript into the equation, our test command isn't any different. We're just running Jest, and our test watch command isn't any different either. We're just running Jest, but we're using the watch flag on that to run a Jest in live reload mode. There's no other changes that we need there. The only thing we have to do now is we have to basically tell Jest to use testbed, and that's something we do in the Jest config. So there's not much in this configuration file. It's pretty simple. Like, it's pretty close to the generated version. So if you're starting a new Jest project and you want to generate this, you can do npx jest-init, and that will create the default configuration file for you, which you can then edit and tweak as you like. Now, it asks you some questions like, whether you want to clear mocks. So it kind of asks you the question and sets that up for you. But the things that I've added here to make this work, I'm telling it to use the testbed preset. So that's what tells it to use the testbed preset, which allows us to run TypeScript code directly under Jest. Now, you might be wondering what this is for. Well, let me explain that. So when I build this code, which I do using npm run build, and that's running the TypeScript compiler in incremental mode. It's building the code. That's built the code to the build directory. And so you can see here under the build directory, we've got a test directory. Let's have a look in that build test. And so there's a test file there. So that's where we have the same basic test, testing that the truth is truthy. But that's been compiled from TypeScript to JavaScript. So we've got, and if you look under the source directory, under the test directory, under the source directory, you'll see our original TypeScript test. So effectively, this project's got two sets of tests in it, one under the build directory and one under the source directory. So it's got the TypeScript tests, and then after the TypeScript's been compiled to JavaScript, we've got a complete other set of tests in here now that are the JavaScript version. And what would happen is if we were to run Jest from this directly, it would just see the duplicated, it would run two sets of tests, which is like going to be confusing. And it's also going to cause Jest to run slower. So that's why we have this ignore pattern here, which tells it which directory Jest should ignore. And we're telling it to basically, off the root directory, we're telling it to ignore everything that's under the build directory. Now, this is a slightly wacky syntax here. Like, why is it like that? I don't know. You would think it'd be like just build, something like that. But no, according to the docs, that's what you got to do. I'm not entirely sure. I'm not an expert on that part of this configuration, but that works. That ignores the JavaScript version of the tests that have been compiled under the build directory, so that you don't have duplicate tests running under Jest. But that's all there is to it. And again, like the previous example, I can run this in live reload mode using npm run test watch, and then I can go into my TypeScript test. There's nothing particularly TypeScript-y special about this, but you can have, you can have whatever types you want in here now because it is TypeScript. And again, should just take a moment to start up. It's going to take a little bit longer to start the TypeScript tests because it has to compile the TypeScript code. And it's not even going to run anything, but I can hit the A key just to force it to run all my tests. And then I'll change this. I'll break my test on purpose. I'm not going to save it until my tests have just finished. I just want to see, I just want to see a passing test over here. So I'm going to save my code now, save my code. It's automatically rerunning the tests. So this is live reload of TypeScript tests under Jest. And before we finish looking at this, I'll just make sure I get my passing test back. That's what I want. I want the green tick of approval. So that was Jest and TypeScript. I'm going to quickly have a look at live reload now in the front end using Parcel. So Parcel is an easy to use front end bundler. It can take a collection of source assets like HTML, CSS, and JavaScript and compile them to a static web page. And you could deploy that web page to any old web server that can serve up a static files. So I'm starting with Parcel because it's really simple to use, unlike Webpack, and I'm going to show you Webpack in a moment. But Parcel is really simple. It has like minimal zero configuration actually in most cases, and it has built-in support for live reload with its built-in dev server. So you can see in this diagram here that we're going to use the built-in dev server from Parcel to bundle our code. serve it as a web page, and then automatically reload our web page as we edit our code. Now, I should add as well, like, I'm talking about Parcel and Webpack, which are kind of two fairly low-level tools. The high-level tools like Next.js and Remix and stuff like that, Gatsby, whatever you want to look at. I use Eleventy for my blog. All these higher-level tools, they all include live reload, or out of the box. But what I'm showing you is a bit more low-level today. So this is how to kind of, a more low-level bundling tool to bundle your web page, and I'm going to show you how to use live reload with it. So this is example number 6. Again, before you start trying to run this code, do your npm install. Otherwise, it won't work for you. Okay, you can see I've already built this because there's a cache and a dist here in the project. Now, what's the best way to start looking at a Parcel project? You'll notice that I've got HTML, JavaScript, and CSS in my project here. So this is the typical assets you'll see in the project for a web page. Now, how I'm building this, if we look in the package.json file, you'll see I've got Parcel installed. I've also got Live Server installed. If you want to learn a little bit about Live Server, please read the blog post. I'm not going to worry about covering that because I'm running out of time. But Parcel is installed here. So there are two things I can do with Parcel. I've implemented the start command here to kind of run Parcel on the root HTML file for our web page. So that's what's going to start Parcel's dev server. So it just does that by default. Live reload is built in. There is no configuration. It is so simple to use Parcel. I really love it. The other thing we're going to have here is the build command. So this is where we're actually kind of, it's basically the same as the start command, except we're adding in this build option here. So that is what's going to tell Parcel not to run the dev server. It's actually just going to build the static web page. So you can try that for yourself if you want. I'm just going to show you the live reload part of this. So I'm going to start. Now you'll notice this time around, we've only got a start command. So this is a difference to some of the previous projects. Previous projects had the start script and the one start : dev. Now, because there is the production mode for this is to run the build and then copy the static website that's generated to our HTTP server. So there's no start command needed here to run this in production. So to follow good conventions, I need to start. So that's what starts this in development. So running npm start over here in the terminal runs Parcel against my index.html file, and it will start the dev server. And in a moment, where did that die? For some reason it's not playing the game. Let me just get rid of the compiled stuff that I had there. I could have also, you'll notice I've got a clean script here, which does that, which kind of cleans out all the kind of artifacts of development. So I could have actually just run npm run clean there, which is like a convention that I use personally. Let's try that again. Now it's going to take a little bit longer this time because it's rebuilding its cache. It's kind of rebuilding all the kind of static web page, and it's ready. So I'm just going to open that web page, and you can see it's a pretty garish website. I haven't really put too much effort into it, but it's a typical Hello World web page, and we can change stuff. We can change stuff here in the HTML. Let's try that. And you can see I've just saved my code and it's automatically updated to Hello Computer. So this is, what you might think of as typical kind of live reload, using it while you're developing a web page. You can edit the HTML, the JavaScript, the CSS, and as you're editing the code, the web page automatically reloads so you can see your updated work and test it. It's very convenient. Okay, so I'm going to leave it at that with Parcel, and I'm going to have a little bit of time quickly just to look at Webpack. So Webpack is a fair bit more complicated than Parcel because you have to have a configuration file, and also because you have to tweak the configuration file in a sort of a non-obvious way to actually get live reload to work. Oh, and the other thing with Webpack as well is that you have to kind of manually install the dev server on top of Webpack. So the dev server is just not automatically included in Webpack like it is in Parcel. But and I still use Webpack on a couple of projects because I have to because it's there. And for cases, sometimes Webpack makes more sense than Parcel, even if it is more difficult to configure. So you can see in this diagram here that the Webpack dev server is going to be watching for changes in our code, and then it's going to trigger the Webpack CLI tool to rebuild our bundle, and then it's automatically going to refresh the browser to show us our updated web page. So let's have a quick look at this example. I'm not even going to show you how to run this time because we're running out of time. But what I am going to do is give you a quick look at the project. So I'm in example number 7 now. Again, run npm install if you want to run this for yourself. If you want to figure out what you can do with it, go to your package.json file, look at the scripts. It'll tell you how you can use it. Check out the dev dependencies. You know, you'll see there's a bunch of things here specific to Webpack. Again, we see live server. You know, for more details on all this stuff, you're going to have to look at the blog post. But what we can do with it is we can run Webpack by itself, which triggers the build command. So that will build our static web page from all our source assets. You can see here we've just got a HTML file and a JS file in this project. Or you can run the start script here, which runs the Webpack dev server and opens the web page for us. Now, the thing that's different here is that this time, unlike with Parcel, we've got this configuration file. And this is a fairly simple Webpack configuration file. Obviously, in production projects, they get way more complicated than this. But this is kind of like the minimum I needed for this particular example. Now, the thing I want to point out here is that if you run this, you don't get live reload working out of the box, unfortunately. In fact, Webpack has 2 separate things. It's got live reload, which refreshes the whole web page, and it's also got hot module replacement, or HMR, which will basically more efficiently, rather than reloading the whole web page, more efficiently, it will reload, you know, components or code modules of the web page as your code is changing. So it's more efficient. Using HMR or hot module replacement is going to be more effective for a large, complex web page. The problem with HMR is it's kind of tricky to get working as well. Like it's tricky to configure it and actually get it working effectively the way you want. But I've found that if you just turn it off, just turn off hot module replacement. That's what this is doing, right? This hot colon false. That's turning off HMR. Then whole page live reload works. It's like this should be the default behavior for Webpack. I reckon if you were running Webpack, hot module reload should be disabled by default unless you want to configure it. But you have to turn that off to get full page live reload working. You have to turn that off, and then you get your live reload where you can kind of run. You know, in this case, I'd be running npm start, and I'll be opening the browser. I'll be editing code and seeing my web page update. But I'm not gonna demonstrate that because we are close to over time, and I've got just enough time for one more example then. And that is the one that I promised, live reload with Docker. So it's one of the exciting ones. Starting to get a bit more complicated now. But if you know Docker already, you probably find this is surprisingly simple. If you don't know Docker yet, you're probably just going to get lost in the details. I'm sorry. But, you know, we can use live reload in a container, and we can scale up live reload to a larger microservices application, which is really cool. Now, again, live reload is something that we only want to use in development. So we don't want to have Docker files in production with live reload. That could be a security risk. There could be performance issues with that. We don't want to do that. We want to kind of, for production, we want to bake all our code into the Docker image and have it not be able to change. The code in a production image has got to be immutable. But for our purposes, for live reload, for development, we want to be able to update the code in a container while the container is running, and then have the server that's in that container restart itself. Now, the good news is that we already have most of the tools we need for this. So Nodemon that we used in example number 1, we'll use it exactly the same way within the Docker container. Now, as you can see in this diagram here, a big part of the puzzle is going to be sharing our source code from our development PC into our container. So that way, you know, if there was separate source code, if there was separate source code on the development PC and in the container, there's no way we can edit it. So we need to find a way to share that source code automatically into the container so that Nodemon can pick up those changes and restart the server. So let's have a quick look at the configuration that's required to achieve that. I'm changing into example number 8 now. You're going to need Docker installed if you want to run this, but running it is as simple as running, I've got it configured using Docker Compose. So you can run Docker Compose up build. Actually, before I do that, I should really open the actual project in Visual Studio Code. So I'll just put that off to the side, and then I'll run that again. Docker compose up build, and then we've got, in this example, we've got one microservice running, and it's just a hello world example again. Like again, there's no need to overcomplicate this to show live reload. I just have to show you that I can restart these processes. So this is going to take a moment to start up. In the meantime, let's have a look at what's in this project here. So you can see we've got a Docker compose file. So that's what allows us to kind of piece together the microservices in this sort of development environment. And then we've got a single microservice. So that this single microservice is just like example one. It's just a Node.js project with Nodemon installed. The only difference is that we've got a Docker file for it. Okay, so we've got this server started, so we've got this sort of proto microservices application running under Docker Compose. You can see it's printed hello world. You can tell from this text here that Nodemon is actually running. So we're just running Nodemon in our container. Nothing too exciting there. And just to prove that it works in Docker, let's say hello computer again. So I've saved my code, and you can see that it's printed hello computer almost straight away. It's restarted. So how do we make this work? Well, let's have a look at the Docker file. So you'll notice that this Docker file is called dockerfile-dev. So that illustrates that I have a different Docker file for development. And normally, if this was a production application, I'd have a dockerfile-prod. So the production version of my Docker file in here as well. So this is a development Docker file. Now, the thing to note here is where we're starting the service in the container, we're running npm run start :dev. So that is exactly the same as what we saw in example one. That's going to run Nodemon. If any of the JavaScript files in the container change, it's automatically going to restart. So you're probably wondering what the rest of this stuff means. Well, you're going to have to go to the blog post for that. But one thing I will note here is that in a production Node.js Docker image, you'd copy the source code in, right? So you do something like this to copy the source code directory from the development computer or the build computer into the image, and you'd bake it into the image so it couldn't be changed. We're not doing that. This all works without that. We don't want to bake our code in, because if we baked our code into the image, we wouldn't be able to update it for live reload. So how does that happen? How does that get changed? Well, the way I do it is I use Docker volumes to share a directory from my development computer into the container. Now, you could do that on the command line using Docker, but it's actually really convenient to do it from the Docker Compose file. So this is the Docker Compose file. And you can see here that we've got one microservice defined in this application. You could have on a bigger microservices application, obviously any microservices application that's going to be, in development for production purposes, it's going to have multiple microservices. So you might actually have like microservice A, microservice B, just to make up some names. Now, the trick here that makes the code sharing work is that we're configuring the volumes. So there's a list of shared volumes here. The first one, we're sharing the npm cache, and that makes npm install really fast. After the cache has been constructed the first time, then subsequent npm installs in the container are going to be super fast. Now, this is the important bit here, the second line here in the volumes. That is what shares the source code. So from under our microservice directory here and under the source code directory of that, it's going to share it into the app source directory in the container, sorry. So that's what shares the code. So whenever we edit the code on our PC or on whatever our development computer happens to be, it's automatically going to synchronize that code into the container, and then Nodemon is going to pick it up and live reload it. So hopefully that makes some kind of sense. I demonstrated live reload happening within a Docker container. It's a really effective way to edit the code for a microservices application that you're running in development, because you could have 20 microservices. Like, some of the projects I work on, I will be running 20 microservices in development. And, when you edit code for one of those, only that microservice is going to update. All the rest, they're not going to reload. So it's very effective. It's not like you have to reload the whole microservices application from scratch. So it's a very effective way to kind of develop a microservices application, incrementally, getting that fast feedback, seeing the results really quickly. Oh, before I get to that bit, the end of the talk, there is one more example, which I'm not going to go through. So I'll leave this for you to explore in the blog post and in the code yourself. But example number 9 is the Docker example, but based on TypeScript. So again, There's nothing new here. It's using, like the previous TypeScript Nodemon example that we looked at, it's just putting that inside the container. So nothing too complicated there. It's just building on what we already know from before. So please feel free to have a look at example number 9 yourself. And you can find that on GitHub, and you can find a bit of an explanation for that on the blog post. So in summary, live reload, it's a very fundamental technique for rapid development. There's so much more to learn about it, though. Obviously, I've just really kind of glossed over the details. I'm going to write more about it in my book, Rapid Full Stack Development. Please join me on Twitter. That's where I'm kind of releasing new content and doing updates about the book and other stuff like this. Thank you so much for listening.
Awesome. Thanks so much. Did anyone have any kind of parting questions? All right, yeah, thanks for joining. Yeah, very clear that we need to maybe do another one on just the containers version of this talk.
Well, I do have a
awesome.
previous blog post on LogRocket.
Okay.
It's in fact, I think it's my first blog post for LogRocket. Crafting build pipelines with Docker, which actually shows you how to build like a production TypeScript application with Docker. So there's two aspects to it. There's the development and the production, and I basically, very quickly, briskly went through, development today. Production's a whole different story.
Yeah,
because there's a whole different set of concerns. But yeah, I'd love to do and maybe even an update to that blog post.
Yeah,
about what I've learned since then. That was a few years ago,
yeah.
And then we could do a talk on that at some point as well.
Yeah, that'd be great. And I think lots to take in from this talk. I think one of my favorite things is just like using Nodemon for just like tracking files generally. Like I always have used it for like, what you'd think it's used for, like tracking lots of like JavaScript files and TypeScript files.
Yep.
Yeah, just like random.
If you're a blogger author, you might want to track Markdown files.
Exactly.
Rebuild your website with like that's you can build your own live reload pipeline that way. But
yeah. Awesome. Thanks a ton, Ashley. And yeah, I'll send this around likely tomorrow Eastern to everyone who signed up. So thanks for
that's awesome.
Thanks for everything. All right.
Thank you. It's been a
See you next
pleasure.
time.
Bye-bye.
See ya.